Hi there and welcome again. We are going to talk this time in our instructional video about what to do with your lab data. This is the lab data connected to our Desiccant lab. So I've opened up a Mathematica document here. You notice I've titled it Desiccant Lab Notes and Data. And this is who I am, and that is today's date. So I thought that was important to list. And the example that I'm going to work through with you was for cobalt 2 chloride. Now that's that purplish red magenta colored compound that I used during our demonstration to show you just how much water there might be within what we call a hydrate or a hydrated compound. So here's the data that I've taken down. You'll recall that you guys figured out the need to mass your system of the evaporating dish and watch glass, and so I have a mass for that. I then turned right around and scooped in some of that wet cobalt 2 chloride, and that's the value I got. And then we cooked it. And let's imagine in this case that we heated it several times, massing it each time, and then we settled on a mass because the mass reached a constant value. So that'll be 25.77 grams. So some of the things that I need to calculate, I need to figure out how much compound I actually sampled, what is its dry mass, and from those two values I can figure out the mass difference, which is really just the water, and then I can figure out the percent water by mass, or if you prefer, the percentage of the compound. Now you'll notice here too I also listed some observations about cobalt 2 chloride, and hopefully this will jog your memory about this compound when we saw it in class. So I want to fill in this data chart, and so what I'm first going to do is going to figure out the mass of the wet cobalt 2 chloride. So I'm going to take my system and that nice wet purpley stuff, purple red stuff, and I'm going to subtract away just the glassware, and I get an answer of 2.161. So I'm going to plug that in there, 2.161. In other words, that's how many grams of cobalt chloride we sampled, including the water. Now let's try to figure out the dry mass. So I'm going to get rid of this just for fun so I can keep everything right there. I'm going to go and take this value, the nice dried sample, after we reached a steady mass, and let's subtract away our container, which was the evaporating dish and the watch glass, and I get a value of 1.179 grams. So that's a big difference. It was 2.161 grams fully wet and loaded with water, and after drying, quite a bit of that mass is left, or has gone. So let's figure out the mass difference. I'm going to again clear this out so it's a little easier for us to see. So the mass difference then would simply be this number, my nice and fully wet compound, minus the dry compound. So I'll copy that and paste that in there, and I'll hit shift and return, and it says 0.982 grams. And if we want to annotate this a little bit, so I can just write down this is grams of water. Alright, so a big thing for us, and a nice way of comparing different compounds, is to look at the percentage water by mass, or if you prefer, the percent of compound by mass. But let's find this for water. So what are we going to do? So I'm interested in how much water there is. That's this. And this time, what I'm interested in doing is whoops, let's not do it that way. Maybe we'll start it this way, with Control and my slash key. And I will take this guy right there, and that's my grams of water. And down here, down below, I'm going to put down the total wet compound. Okay. So remember that whenever you do a percentage, you're always doing a part, the small part, the grams of water, compared to the whole, in this case, the compound full of water. And I'm going to times that by 100 because I want this to be a percentage. So I'm going to type right in here, 45.4. Now, if you look at this, you'll notice that I took only 3 digits here, and that's because when I look at this answer, this is the grams of water, I see only 3 significant digits. This leading 0 is not significant, but 9, 8, and 2 are, so there are 3 in this value. The total compound mass was considerably heavier. It has 4 significant digits, but the rule in division, just as it is in multiplication, is that my final answer has to be trimmed so it has the same number of significant digits as the building block with the smallest number of significant digits, in this case 3. So 1, 2, 3. I'm going to have to stop right there at the 4, and these values are less than halfway to the next digit, so I'm going to resolve this as 45.4%. So this number, 45.4%, That sounds like a pretty large number. Almost half of the mass of the compound we sampled is water. The higher that number, that means the more water our dried compound can hold, right? Or if you think of it the other way, it's how much of the weight of what we started with was really water. The higher that value, the better we think it might be as a desiccant. But there are other factors to consider about the desiccant, and I'll talk about that in our next video.